Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Hello, everyone. Welcome back to another exciting edition of IT Pro TV. I'm your host, Vaughn Smith, and this is our Cisco Cloud Fundamentals exam series. And this episode, we are going to talk about SDN basics. I practiced that like at least 6 times before we started recording, but I still forgot. But that's okay. We have somebody here that can remind us about everything we need to know. It is Mr. Ronnie Wong. How are you?
I am doing well, Vaughn. Thank you again for joining me as we now head into the more mysterious side of the networking world and, of course, cloud fundamentals themselves, which is the realm of SDN, is what it actually is. And Vaughn, do you know what SDN stands for?
Software-defined networking.
Software-defined networking. Okay, so very good, Vaughn. A big check mark for you.
That I can read the notes that are on this piece of paper.
Sure, that actually does help. When we start doing it. Okay, so the realm of software-defined networking. This is where most of us, if we've been traditionally grounded in the way that we are used to doing things, especially in the Cisco line, which is the command line interface. SDN all of a sudden sounds like a very scary acronym. Software-defined networking, okay? And for those of us that kind of said, all right, I kind of can get the idea behind it, but I don't know exactly how it works. Well, we're going to talk about the very fundamentals of the idea of software-defined networking, where it came from, and of course, what it is, and what is it that we are accomplishing or trying to do is what we want to be able to get down and access and understanding of, and of course some of the different protocols that we are going to line ourselves up with or understand a little bit more if we're going to be using software-defined networking. Okay, this is one of those buzz phrases, Vaughn, that's been around at least for the last 2 to 3, if not even 5 years now, that everything's moving towards software-defined networking. And so, is it a term that we should be very familiar with? Yes. Okay. Is it something that we've got to know ins and out of? Well, you at least need to know the basics to get started. You don't have to become a master at it, but you do need to at least know the basics. And then, of course, the more that you work on it, the more you'll surpass my knowledge of software-defined networking. You'll feel very comfortable in the realm and environment that we're talking about. Okay, so when we start to understand, okay, for those that don't have the background or experience in terms of working with the Cisco command line, let's at least review that for a moment before we do so, okay? So traditionally, right, in terms of Cisco devices, right, whether we're routers or switches that we tend to deal with, okay, the majority of the times what we're doing is we are typing in individual commands is what we're doing to configure that particular router or that switch, okay? A lot of times it actually comes down to even configuring a single interface and adding in at least the IP address to that interface, if not more, making sure that the interface itself is not shut down. You name it, it's actually a fairly manual process in what we have to do. As you begin to, of course, work with the routers a little bit more, you might implement a routing protocol. You might implement the idea of performance-based routing, okay, is another thing that you can actually be able to do. So there's a lot of other things that you do, but all it's done, Vaughn, essentially by going to that router, consoling in, or coming across network using Telnet or SSH to make sure that we can get in there and we begin to type the commands and the configurations that we want, okay? And if you actually are fairly good at it, that means you'll go on towards your certification for something like CCNA routing and switching or even CCNP routing and switching as you start to learn more and more about what you actually can do. Now, Vaughn, because of that, right, this particular certification has actually been one of the harder certifications to earn in terms of a CCNA. But we're also starting to see a change in networking today. But some of the issues that you and I will have, especially if we're coming from that background, is to understand that it is not only the idea that we're switching from the understanding here of typing in commands, okay, but we're really fundamentally changing the understanding of how in the world configurations can even be accomplished. So when we start talking about the idea of some of the processes here, okay, one of the goals that we might have actually tried to achieve on as we started working with multiple switches at the same time or multiple routers at the same time is we tried to get faster at this, okay, especially if the configurations are fairly easy and identical to do so. So Vaughn, at the very beginning of the idea of what we've tried to do is that we probably tried to actually implement something that made things faster. Does that make sense? Because we were working with multiple switches, okay? So Vaughn, let me show you how we actually do that. So let's take a look at my screen here. And I tried to kind of populate this in a way that would actually make sense here. So the initial program goals, at least from my experience in working with multiple different routers and switches at the same time, we would try and speed up the network configuration process is what we would try to do, okay? And the way that we traditionally did that is something like this, Vaughn, okay? Is that what I would do is I would go ahead and let's say I had 3 different routers over here. I would configure one of these routers exactly the way that needed to. And if I realized that routers 2 and 3 here were going to be fairly similar, okay? In other words, I knew that they were going to have the same number of ports that I would have to configure. I knew they would be running a routing protocol that would have to be configured on there. I knew that there were, other things such as securing the access to the routers. I could get all that configured, and then what I could do is I could run the command here, right, to actually show running -config, and that would spit out, of course, the configuration, okay, that I wanted onto the screen, and then I could simply copy that, and I could paste it directly into a text file. So Vaughn, when I did that, then I could save it, and let's just call it r1_config here .txt. I could make a copy of that, and then I could open up the copy, and then I could actually just change what I needed to. I could change the host name from R1 to R2, okay? I could change the IP addresses in that config file, even though it's not on a router. I could change it to the IP addresses I needed to. I could add in all of the same configurations that I needed, except for, of course, the idea here of actually running SSH, which we'd have to do on the individual routers that generates a new key. I could do all that, okay? But the way that we did that is now that we had individual copies of that, now I would run those other 2 routers, get them up and running, and then I would go over here to my text file, do a Control-A, and then I'd simply click on that router console interface, and it would just go ahead and paste all the configurations on there, and that router would be up and running in very little time, okay? So Vaughn, that is by far my most basic attempt at the idea of programming in terms of Cisco routers, okay? Now, it's not really programming, right? I'm essentially taking the hard work I did on router 1, and I'm duplicating it. But to a point, I'm changing it as well. But instead of me having to type it in 3 times and then remembering all that, I can type it in here. And the advantage of this is I could save it and reuse it later on if I needed to, okay? So it'd become a backup of my config. Now, this can also be done through a GUI management. And Cisco, of course, has something that they call, of course, a type of network management system. And they are very proud of theirs that they call the Cisco DCNM. Go figure, okay? The Data Center Network Manager itself. So what that would actually end up doing for us is it would do the same thing, but it would actually allow us to go ahead and batch together all of our CLIs that we needed to and be able to actually send them out to multiple devices. So Vaughn, I didn't actually have to worry about the idea here of whether I turned that device on. If those devices were on, they were connected network, I could go ahead and send them out. The DCM would be able to find them and do the configuration for us, even though I went ahead and actually had that copy of those CLIs right there. So those were 2 ways, but the initial goal was simply what? Speed up the actual configuration process, okay? So that's all it was doing. So Vaughn, notice that it actually kind of keeps in line, okay? The very fact is I'm still using the command line to do so, okay? In both instances, right? In this one, it's still the CLI that I'm copying and pasting it back in. Even in this one, it's still batches of the CLI that can be pasted to multiple ones too. So that speeds up the process a bit. But when we start turning to the idea of SDN, okay, the software-defined networking then, there are other goals in mind that we also have to change. But the primary goal behind SDN, okay, is that we actually come up with a shift in understanding how configurations can actually work, can be accomplished here, okay? So that is the key when we start thinking about it, okay? So in the same way that virtualization is really us taking the idea of a computer, a physical computer, and making it virtual, in other words, making a copy of it in this virtual world, that's exactly what I was doing. I was thinking about it the same exact process here, but just trying to speed up my configuration by making copies of it and do so, okay? So hardware then, if we were actually to do this, would have to be purchased over and over again to do so. But when I virtualize it, I don't have to worry about that. I just make a file, and then I can actually deploy that, and now I've actually created that machine very quickly, okay? So it allows us to be able to do things a lot faster, but that's not the ultimate end goal behind what we can do, okay? Now, the reason why this is important in the cloud world, okay, and the terms of cloud networking is the very fact, as we go back to the definition of cloud computing itself, it reminds us of those factors as well. That cloud computing should be what? On demand, okay, as we need it, as far as serving what we actually need up. The idea of elasticity, which means we can grow and expand and contract as we need to. Resource pooling, the ability to actually share resources even with other customers and still have them partitioned the way that we need to. Metered services, in other words, we pay for what we use. We don't pay for things we don't use. And then, of course, the idea of ubiquitous network access, okay? In other words, we can access it using anything that we want to, okay? All of that stuff that we've talked about, okay, they can't be easily met in the cloud if we don't have another way to do this besides, Vaughn, of me copying and pasting all these configurations into a cloud environment, okay? So it doesn't help if I don't have this idea that I have to figure out a change or a way of thinking that devices like virtualized switches and virtualized routers and ASAVs, I was trying to make sure, firewalls. In other words, if I don't know of a different way to be able to configure them as well, okay? So when we start to do this, we actually have to think that there has to be a different way, and that's what SDN does for us, okay? So the way that software-defined networking is doing is that what they're actually asking us, especially in the cloud environment, how do we do what we need to accomplish, but do it better, okay? So one of the problems that we have, of course, is to understand that with multiple types of networking devices, Vaughn, if I'm having to go around and configure 25 or 50 different routers or switches, okay, there's going to be a chance of what we call human errors, okay? And the idea of human errors comes from the fact that Ronnie makes typos all the time, okay? If you ever watch any of the other Cisco shows that I'm typing in command line, you'll see all the errors that I made. It's very easy to make typos. But the other thing, Vaughn, is I get easily bored, okay, at some of the things, right? So, Vaughn, I have a list of things down here in the lower left-hand corner of the screen that I would normally need to do, okay? So in a cloud environment. So let's say create VLANs. Then I need to add vPorts into the VLANs, right? VM, their NICs into the VLANs as well. I need to configure default gateways, and then I need to make sure that everything is actually done and checked every way that I actually need to. All right, so Vaughn, if I do this, let's say 10 times, Vaughn, what are the chances that I'm going to do all 10 of those exactly in the same order? After a while, probably after the second one, I might go, oh, I want to create these ports first. I'll create VLANs later on. And then the third time, I'm going to create default gateways first this time, and then I'll go back and add these ports in. I'll create different VLANs. I'll start doing this. So Vaughn, in that sense of things, right, in terms of human interaction, the more often that you give me the ability to essentially mess up, Vaughn, more than likely, excuse me, I'm going to take that advantage and I'm actually going to mess up, okay? So what SDN says is, hey, why don't we actually figure out what we need to do to really reduce this idea of human errors as much as possible? And some of the ways that we can do it is by simply saying, Ronnie, why don't you actually just tell us what needs to be done so you don't really have to interact with it, but I will interact with it, or we'll actually go ahead and use software to interact and do what we need to do, okay? So SDN essentially works in a couple of different ways. At the very beginning, at the most fundamental way that SDN begins to work is that it begins to tell us to reduce the idea of human interaction. Vaughn, let's set up some network automation, okay? That network automation for us means I will automatically do what these things are to do, okay? Whatever it is that you've actually set up. So let's say it's this list of stuff that we have ready to go that needs to happen, okay? So Vaughn, when I do that, I can go ahead and also configure what order those things need to be done in, okay? And then we can use network automation and tell it when it's to do so without me having to stand there and go click, 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 type this in, click, type this in, do that. So what we can do is actually have that ready to go. And the nice thing about both network automation and workflows is that once we set up the automation and the workflows will do what? It will go ahead and do this exact order of things if I want to, okay? Make sure everything is done and completed and checked in the exact same order every time that I want it to run. I can also guarantee something, Vaughn, in terms of network automation. If there are 50 routers that are out there, or 50 switches that are out there for us to do this, I can guarantee that they're not going to go to number 45 and go, did I just configure 43 or 45 of these things and wonder if I've actually done that? The network automation will make sure it actually goes and does all 50 of them for us, and we not have to worry about it as well, okay? So combining that together, what we call an orchestrator, essentially the guy that actually puts it all together and can do all the things that are in this workflow and work according to when it's supposed to happen. The orchestrator then can carry out exactly what it needs to in the overall virtualized infrastructure. Now, this is not exactly how it looks like in the cloud environment, but for you and me, right? We talked about it at the very beginning of our entire series here, that we can't think about it as just software that's out there. If we're actually going to be configuring this, we need to have at least a logical understanding of essentially here's how our network is built out, right? We have our layer 3 router, we have our layer 2 switch, we have our VMs, and of course our physical hosts that are out there. So in every tenant environment, we can actually use software-defined networking to create a workflow, to make it automated, and to have the orchestrator essentially command and do that regardless of what device it's actually on to do so. Now, Vaughn, this is different than what I was showing you just a moment ago when I talked about this. Vaughn, this configuration works for routers, but what if I actually need to deploy this for things like switches? Well, they don't work for switches that way. I'd have to create a whole new set of different configurations for switches. And if I also brought up a Cisco ASA, I'd have to configure a whole different one for that as well. And if I actually need to create VMs, well, that would actually be different too. Well, in the idea of SDN, it's actually saying, hey, what if all that can actually be done through software-defined networking? In other words, that different approach that we were talking about of understanding how things can actually be accomplished, but in a better manner and a better way than just one person trying to do everything else that we need to, okay? So that is where software-defined networking pretty much has its basic goals, okay? Now, the overall goal of understanding and pushing this, which is what Cisco is doing, okay, all along, is remembering that they are trying to change our way of thinking, okay? Now, it's hard for us to understand that. It goes from the idea of networking as being configurable, okay? You and I working in the command line to say, no, networks can be completely programmable, okay? And that is that change of thinking that we're talking about. It also means that we can create different customized solutions for what we need to by using programming instead of me having to learn a whole new command line language. So Vaughn, right now, we want multi-vendor inside of our cloud environment, inside of my network. Let's leave the cloud out of it for right now, okay? So if all of a sudden I started choosing more than Cisco, hardware to work with, and if I'm not as familiar with things like the HP Pro cards, a bit older in terms of the stream of devices that we're talking about, or even Juniper routers that are actually out there, if I don't know how to configure those, Vaughn, and I'm still in this configurable stage, Vaughn, what do I have to do? I actually have to learn how to do what? Configure Juniper routers. I have to learn how to configure HP switches to make that work. Vaughn, what's actually having to change is not what? Is the way that things can be done in programming. I'm having to learn how to configure those devices. Whereas if everything is programmable, we're not actually having to write programs for every single device. Now, don't get me wrong, there are some things you might have to. But overall, though, with software-defined networking, it is the programming that changes, not so much the person that is doing the configuration, okay? So that's what leads us to faster and better changes too. Creating the customized solution that we need. Being able to also reuse what we call code sharing. Some of the things that we've learned in other times that we've actually used software-defined networking, it can help us out. So all that is combined together to do something that we call creating some type of network application to do so. Network applications, for example, can end up taking a look at our entire cloud topology and scan them for whatever the existing VLANs are. You might be wondering, why the heck would I do that? And so that if I create a new VLAN, what's going to happen? I don't actually try and overlap one and then go, I don't know what VLANs are available. So we can actually create an application that does that for us, okay? So that also then helps us determine what VLANs are free for the next tenant to be able to take advantage of, okay? Then we can even go ahead and also tell it that if you do this in terms of an application, then configure a VLAN for that brand new tenant as it comes up. We can also, of course, then add in the VLANs that are necessary to the hosting servers that the new tenant will also have access to. And then, of course, scan the cloud. Oh, apparently, I didn't spell it topology. Topology, okay, for routing, configure the default gateway for the new VLAN as well. So, Vaughn, we can actually use software-defined networking that does all this stuff for us that we see here in this list and not have to worry about creating or figuring out new languages to do so, okay? So, Vaughn, that's where software-defined networking is really leading us to and desiring for us to get to, okay, to do what we actually want to be able to do. Now, in saying that, there are different elements, of course, in terms of software-defined networking, okay? Now, I went ahead and I connected these together because it's a little bit harder, but I wanted to make sure that you actually could go back and check this out if you want to. Now, in terms of definitions, though, okay, I'll just move that up so we can put my face back on screen if we need to, okay? So I wanted to make sure that we understood how these things work, and my advice to you is to go ahead and search for these terms inside of the Cisco documentation that's online, because what you're getting here are the Ronnie Wong kind of basic definitions of what we're seeing. So that's key. So all these are essentially software-defined networking terms that you should be familiar with before you go into the exam, okay? So Vaughn, when we take a look at it, API stands for Application Programming Interfaces here, okay? Remember that an API for us, what it really allows us to do or allows programmers to do is not have to learn about every single detail behind my network, right? It allows them to connect to the API, and for the developer that's actually writing some type of app to connect in, they're only actually writing it to verify that it can work inside of what the API. So it essentially simplifies the entire network for people that are actually doing app development, okay? And that makes it much easier because it's more of a descriptive type of thing that we're doing rather than a prescriptive type of thing, okay? The other thing, of course, are different types of embedded programming languages that are also out there as well. So an example of an embedded programming language, of course, is something like a Python interpreter that can be found in many different programs that are out there too, okay? So realize that that's a part of it too. Network controllers that are also out there. Network controllers make it very simple for those that are writing source code for developers as well, so that they actually know how to actually be able to control those things. Most of our Cisco devices run ASIC firmware. Remember, ASIC stands for Application Specific Integrated Circuitry, and that provides access to lower layers or lower level software, and that is because software is embedded directly onto the chip itself. Application hosting is a weird term for us too. Network devices with dedicated hardware so that they can host different apps that are also out there as well. Configuration management software. These examples are going to be very important. Make sure you understand things like Ansible, Chef, and Puppet. These are all things that help us to manage our software as they're actually run. And then this weird acronym here, XMPP, Extensible Messaging and Presence Protocol, open source technology used for IM and presence, okay? Now that doesn't sound like it's too much, but what I would do is make sure I look up these definitions according to Cisco's terms. You might be wondering, why didn't you just copy Cisco's terminology down? Well, because, well, that would be not good for me to do that on the show that I'm doing. So my recommendation, of course, is that you look them up. I actually put them in terms that I understand. So that's what you want to be able to do as well. Highly doubtful that you end up doing a matching game on the exam of all these terms, but it is likely that you will be asked about some of these terms as you get ready for as you actually go into the exam as well. Okay, so don't think that it's not possible. Okay, all right. Now, when we start talking about a couple of different things here, okay, so we still got a little bit of time as we go through. There's also something else we need to know about SDN, which is, of course, the way that things actually end up working in SDN that we call using open daylight, okay? So when we start using SDN, the SDN communication between controllers and networking devices, that's what we want to take a look at. Over on the right-hand side, I essentially tell you where you're actually going to find some of this stuff working. Okay, so notice that we have two layers that are going to work with what we call the northbound interfaces, and then southbound interfaces are on another layer as well. Okay, so what we want to actually understand is that when we start working with SDNs and the communication, it's actually between these guys, the northbound interfaces, and of course also the southbound types of interfaces as well. Now, the reason why this is key is because it's not as intuitive as it seems. All right, so Vaughn, southbound interfaces, that at least makes sense to me, right? If I think about it from the idea of the application that I'm running, okay, I want to make sure that the application that I run absolutely can communicate with what? These virtual devices, right? If I want to configure them, if I want to do whatever I want to do with them, I want to make sure that those actually get down there, okay? So we can run from our service abstraction layer all the way through these other protocols here to be able to make sure that our commands are actually heard and learned as well. But Vaughn, the weird term though is northbound interface, okay? So when I first started learning about this, I thought, oh, northbound interfaces, it makes sense, right? We essentially go from our data plane elements, in other words, the devices that we're running, and that should be what? Where it removes up the stack. Does that make logical sense?
Mm-hmm.
Yeah, you would think so. And then you actually read about it and you go, that doesn't actually make any sense at all. Northbound interfaces are not actually from the southbound devices going all the way up to the northbound devices. But Vaughn, when you look at this here, okay, there's actually an API here, okay? So notice that there's actually what they call the ODL API, the Open Daylight Application Programming Interface. And that means, Vaughn, these particular applications here, okay, these are all the ways that we would connect in as users or as programmers, okay? So northbound interface essentially is how we actually communicate with the end user, okay, or the programmer is what we do. So as long as it's actually coming in and out of the application from the programmer to the application, that's called northbound, but the application to the actual direct devices, that's southbound. So it's not the idea of your applications directly communicating up here. Those are the differences here, okay? Open Daylight's architecture, you don't have to know everything there is about it. But part of software-defined networking, all that was actually developed underneath a particular program at Stanford University called the Clean Slate Program, okay? It is what actually produced the idea of SDN, as well as this protocol over here on the left-hand side that we call OpenFlow, okay? OpenFlow was really one of the very first protocols that was used to help us to make sure that we could actually communicate and control the idea of the descriptions from the SDN controller all the way to the networking devices as well. So they had an open standard that they said, yes, we can actually talk to all of these different devices that are out here, so it's very possible, okay? So there are, of course, different devices that run OpenFlow. Those that run the open standard types of protocols like vSwitches, okay, are also out there. And then you have vendor-specific interfaces. These are the ones that are not open standard ones that you'd also have to be able to communicate to as well, okay, using SDN too. So that also helps us to do this. Now, even though that was kind of the initial aspect of what SDN would do, it really only functioned based on this idea of the southbound interface, okay? So that meant it didn't do anything for the northbound side. Open Daylight itself said, we need to figure out the rest of this communication path. So it was Open Daylight that filled in the service abstraction layer, the idea of the controller platforms that are out there to make sure that they could function, the idea of actually running an open type of API and then allowing the end user or the programmer to choose whatever application that they wanted to, okay? So Open Daylight essentially provides for that, and it is a multi-vendor open development architecture to help solve any of the problems that they had before, instead of having to actually go, all right, we don't have an API yet to connect in. You got to actually understand SDN. So it's strange, but SDN is now considered a little bit older in that term, whereas Open Daylight, right, as we start to move forward, we're going to see that there's actually newer things that are actually done in terms of networking programming that we're going to end up seeing. So overall, though, just realize that Open Daylight itself is that other part of that connection that helps fill in that gap between the idea of that southbound as well as the northbound types of interfaces that we will actually have to worry about, okay? So the overall nature of SDN itself, remember, it is about changing our minds about how networking can be done in terms of how do we actually configure them, okay, and what we can actually do using network automation, using, of course, some type of programming to get done what we need to, and that includes that idea of the orchestrator, as well as building in workflows. So there's a lot of that's going on, but Vaughn, this is really the beginning. It's strange to understand that, but we still need to go through what we call ACI, which is the application-centric type of infrastructure that we need to actually think about here, and we're going to actually take a look at that as well in an upcoming episode. But Vaughn, for right now, at least that should help you to get started understanding more about SDN and what it does for us. And then we'll actually start talking about the idea of ACIs in another episode, and that should wrap up at least a lot of our network programmability that the world is really heading to today.
All right, lots of great concepts and terminology to test ourselves on and know about. So thank you so much, Ronnie, and thank you out there for joining us. But we're going to go ahead and sign off for IT Pro TV. I've been your host, Vaughn Smith.
And I'm Ronnie Wong.
We'll see you soon.
Thank you for watching IT Pro TV.